going to be talking about bisectors. Bisectors, if you think of the word bisector, it's something that cuts something in half. So there's different kinds of bisectors. First we'll talk about an angle bisector. An angle bisector is a segment that cuts an angle in half. For example, here's an angle, and this right here would be a bisector if this angle and this angle were the same. There's also a segment bisector, and a segment bisector still is something that cuts a segment in half. So if here is a segment, it could be a line, it could be a point, but as long as this and this are the same, then it's a bisector if it cuts it in half. We're going to be looking at different kinds of angle bisectors. So here's some examples. First of all, it says we have an angle ABD. Alright, I'm going to draw that. The letter in the middle is the letter at the vertex, and then A and D are just on the outsides of the angle. Okay. It says CB is a bisector. Well, here's B. We don't have C yet, but it's a bisector, so we're going to just draw another ray or segment. And here's C. So CB is a bisector of ABD. And so here, these two angles are the same. So first of all, it says if ABC is 38, what is CBD? Okay. So ABC, notice this ABC is the little part. ABC, so it's this part right here. It's 38. And so it says, well, what's CBD? Well, if this is a bisector and this is 38, this is also 38. Then it says, what is ABD? So if this is 38 and this is 38, you add 38 together twice, or do 38 times 2, and you'll get 76 for ABD. Okay, let's look at the next one. CBD. CBD. So we're talking about this little angle here is 63. So it says, what is ABC? Well, if this is 63, this is also 63. Then it says, what is ABD? Again, ABD is the whole big angle. So we're just going to add 63 together twice, and we get 126. And I know that this doesn't look like 126. That just means our picture's not drawn to scale. It was just to help us figure out how to do the problem. Okay, next. ABD is 88. This is the big angle. ABD is big. See, these were all the little parts, and because they were little, we know that the other part of the little came out to be the same, but this is the big angle. So it says, what is CBD? CBD. So it wants the little angle. The big one's 88, so what's the little one? Well, we divide it by 2. Then it says, what's ABC? Well, that's little also, and they're both the same, so this is also 44. Now, with bisectors, we also want to be able to find x. So let's look at that. So it gave us a different situation, so I'm going to draw it. It says FEH, so here's F, E, and H. And it says EG, so this line right here, is the bisector. So I know that these two are the same. Alright, it says FEG is 3x minus 8. So I'm just going to put that in there. FEG is 3x minus 8. And it says FEH, oh, that's the whole big old thing. So all of this is 2x plus 4. And it wants us to find x. Well, if this is the little one and this is the big one, and I know this was a bisector, I'm going to multiply this little one by 2 to get the big one. So I'm going to take 2 times 3x minus 8 and equal that to 2x plus 4. And then I'm going to solve. So 2 times each of those, 6x minus 16. I'll move the 2x over here, so 4x. Move the 16 over here, and 20. Divide by 4, so x is 5. Okay. All right, so let's look at the next one. I'm going to draw the picture again just so we can write in the information that it gives me. It's the same picture as it described up here, so still F, E, and H with EG in the middle. Okay. FEG is 2x plus 5. GEH, oh, that's the little one. They're both the little ones. Is x plus 2. It says find x and then find the angle. So we'll worry about the angle in just a minute. Alright, since both of these were the little parts, I know that those just equal each other. Subtract x on both sides and subtract 5. So I get x is -3. Now, it says to find GEH. GEH is this angle right here. So I'm going to take x. It says x plus 2. I'm going to put the -3 in the x place. And it looks like I made up a very bad problem because an angle can't be negative. It's okay for x to be negative, but the angle can't be negative. But that is the process about how you do what you're doing. You shouldn't get a negative angle. I just made up a bad problem there. But that's the process that you would use to solve it. Alright, we're going to look at some other types of bisectors. So, we kind of talked about what both of these say, that what happens with bisectors, but let's look at this theorem that it says. If a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So it's saying if B is on the bisector, that this and this are the same. So if you see a picture like this, what it's telling you is that if I know this side, I can find this side, and those two sides are the same. So let's look at some examples here. So number 1. Oh, by the way, if these are the same, the angles are also the same. And that's what this is telling you here. So the angles are the same and the sides are the same. Okay. So on this problem here, it tells me the sides are the same, so I know the angles must be the same. And it says to find x. So I'm just going to take the two things, 4x minus 6, equal them to 3x plus 5 and solve. Subtract 3x on both sides, add 6, and I get x equals 1. Okay, number 2. It does go down. I'll come back up here in a second. It says to find x again. Well, these were the same, so these were the same. So I just have to set those equal to each other. So it's just a bunch of solving equations. I'm probably going to subtract 6x over just so I don't have leave something over here and divide by -1. So x is 5. Okay, number 3. It tells me that BD is an angle bisector, and it says the measure of angle ABC is 4x minus 6. So this whole big angle here is 4x minus 6. And I know the little part is that. So this is kind of what we did just a minute ago. We're going to multiply this by 2 to get the whole thing. So 2 times x plus 6 equals 4x minus 6. Multiply by 2. Subtract 4x on both sides. And subtract 12. Divide by -2. So x is 9. Okay. Again, we have a bisector here. It says find the value of x if BCA is 80. So that means this whole big thing is 80 here. Well, if that's 80 and we've got a bisector, I know that this is 40. So I'm just going to take 3x plus 1 and set it equal to 40. Subtract 1 on both sides. Divide by 3. Okay, last little thing I want to show you is about a perpendicular bisector. And it says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So here's a perpendicular bisector. Bisector means it cuts it in half, but perpendicular means it does make a right angle. But what it tells you is that this side and this side are the same. whenever this lies on the perpendicular bisector. So these are the same, which also means the angles are the same. Now some of the problems that you're going to work with, and the answers are just numbers, but I'm dealing with the equation ones just because maybe those are a little bit harder. So number 1, it says find the length of AB. So I'm trying to find this side. Well, in order to find this side, I need to find x. So I'm just going to set these two things equal to each other, because that's what the problem tells me up here. Subtract 4x on both sides, I get x equals 3. Alright, this says to find AB. AB is this side right here. So I'm going to take 3 and plug it in right there. So 5 times 3 is 15. So 15 is my answer. Just be sure to look and see what it's asking you to find. Example 2, it says to find AB. Well, I know these two are the same. Subtract x on both sides, that's the way I would do it. Add 6. Divide by 2. Alright, I have x. But now it says to find AB, so I need this right here. So it says x plus 18, so I'm going to take 12 plus 18. I get 30, so 30 is my answer. Okay. Similar kind of question again. These two things are equal to each other. So subtract 3x. Divide by 2. It says to find AD. So I'm going to take the 7 and put it in right there. And I get 35. Last one. I know this looks weird, but if it's a bisector, those two still equal each other. I'd probably subtract 2y on both sides and add 7. Now it says to find AC. AC is this whole thing, so I'm going to find one part and then just multiply by 2, but you could find both parts. So I'm going to plug in a 5 right there. And I get 13. Well, 13 is just this part. That means 13 is also that part. So what I'm looking for is 26. I want you to know, though, that some problems are really quite as simple as they look. For example, this says find YW. Oh, well, that's 7.3 because these are the same. So that's all you would have to do here. This one, it says find BC. All right, if this is 16, this is also 16. So BC is the whole side, which means BC is 32. So sometimes the questions are really, really simple. Here it says find LM. This is 12.8. Well, that's also 12.8. This one, it says that ABC, which is this whole big thing, is 112. It says to find ABD. Well, because these are the same, we know that the angles across from them are also the same, so I just divide 112 by 2, and you get 56. So I just wanted you to realize some questions will not be equations, some will be very simple, just like those.